MVC, and then post that we'll look at the installation of SQL Server, fix that and start with the demos. Okay, so the objectives that we are going to try to meet during this session now is we're going to discuss before MVC, how did ASP.NET Web Forms work? Why do you need ASP.NET MVC? What exactly is MVC? We'll have a quick discussion of model view controller, routing. We'll look at the Razor engine, and through the 3-4 days we will understand how do we integrate Bootstrap, Ninject, Mock, EF and jQuery with MVC. Okay, so we're also going to touch up a little on something called as bundling, SPAs. Okay, what is SPAs? How do you build it? And some amount of Ajax and knockout if time permits. Now to get to the architecture of ASP.NET MVC, this is the basic stack that you have. So I'm going to start with phase 1. So first, obviously you have your operating system that is sitting here. On top of it you have the .NET framework that is running. On top of it you have the ASP.NET runtime which is running. And now you have two options to build your applications. Either you choose ASP.NET Web Forms or you choose ASP.NET MVC. Okay, or the third option is you go with a blended mode. You have some of your pages in MVC and you have some of your pages in Web Forms. So those are the three options that you have when you try to build an ASP project. Okay, now it depends on the editor that you have. If you have a Visual Studio 13 editor, it will still allow you to inject a web form into an MVC project. Okay, but if you have a 2015 editor, Visual Studio 15, it does not allow you to inject a web form into a classical ASP.NET MVC project. If you select type MVC, it expects that you use a view engine. Okay, and what are view engines? I'm coming to that. So for your information, as a developer, you have three strategies that you can follow. Either you use a pure web form, or you use a pure MVC, or you use a blend. You go with some web form, some MVC. Okay, now you will ask me why Microsoft did this, why so many options. That's because if you have a traditional web form, okay, the backward compatibility has to be maintained. So Microsoft could not kind of dump everything that they've created because there are applications already functioning in the web form base. So they have to keep that running. So the web form thing also, you export it into Visual Studio 15 as a project, it will run. You can edit it. You want to go with the MVC structure only, you don't want any web forms inside it, fine, you can go with that. And some customers are asking developers to, why don't you migrate? So they're saying take the old stuff, migrate it to the new stuff and then build. So for things like that, you need a blended mode. So you need some bit of the new stuff that you're building in MVC, and you need backward compatibility with web forms that are already there, and hence you need a blended mode to execute your app. And that's the reason we've got these three options. Now, what was the problem with web forms? Why in the world did Microsoft go and actually come up with this concept of MVC and all that? The first thing was view state. Okay, what is view state? There are different ways in which you can maintain state in a web application in the .NET domain. Okay, there are state management techniques on the client side, and there are state management techniques on the server side. Okay, Mayur, I will take your questions separately. So, okay, I think you're back now. So, yeah, I'll just go to the slide behind. So, what we discussed, Mayur, was when you create an application, the first layer that you have on top of your OS is the .NET framework. On top of it, you have ASP.NET framework, and on top of it, you have the web form option or the MVC option. Okay, two options in which you can build your app, and you have a blended mode as well, and that's for the backward compatibility. So you can have part of your app in MVC. You can also import some web forms as views and run them. But if you're using Visual Studio 15 as an editor, it shies away from allowing you to import web forms out of the box into an MVC app. It prefers that you use a view engine. Okay, and I'm coming to what a view engine is. So we were discussing what are the client and server side state management techniques. Okay, so let me list them. So on the server side in ASP.NET, first of all, you can maintain state in a session object. Okay, so whatever data you store in a session object is, now I'm assuming that all of you are aware. I was told by Harish, who was the technical Spock I had a discussion with before I took this assignment up, that you all are already aware of ASP.NET Web Forms. So if anyone is not aware of ASP.NET Web Forms or how ASP.NET apps work, just kind of put me that in the chat window and I'll touch upon that, else I'm assuming that you all know. So session state is the first kind of server-side state management technique, and session state is always per user. Okay, so every user stores individual session data that is available on the server side. Okay, then you have application state. Okay, application state is shared among all users. So all users would see the same data that you're actually showing there. Okay, then you have a cache. Okay, a cache is also shared among all users. Okay, so every user connecting will continue to see that data that you are putting into the cache. That's the standard way it operates. And then there is client-side state mechanism on which you can hold state. So for client-side, you have hidden fields where you want to store one or two characters of or some flat value that you want to hold in the page. You have a hidden field. The value is only available until the page is visible on the screen. The moment the page object is destroyed, that value is gone. Then you have cookies. Cookies, even when you log out from the website, you still want to hold information. When the user next logs into your page, in that case, you store cookies, you store the data and cookies onto the client machine. Okay, and then you have query string. For query string, you store the data as part of the URL, and once the user closes the browser window, that data is lost. So it is again temporary. Cookies is permanent. Hidden fields are temporary. Query string is temporary. And then with .NET, you have view state, where you store the data encoded into the page, very similar to a hidden field. The problem with view state is that on every request and response cycle, the view state is sent to the server and then pushed back to the client. Okay, so and every request response, the view state is traveling, and hence it is slowing down performance. Now that is one major concern with a traditional web form, because of which in MVC the view state has been dropped. Okay, so by default view state is not maintained in your applications. So the view state we have discussed, it goes back and forth with every request, leading to slower response time. The next is the page lifecycle issue. So I think we are all aware that ASP.NET has a huge number of events that trigger when the page, before the page is loaded. There is a render, pre-render, load view state, second attempt for controls that are injected on the fly. And that kind of slows down the page, and it's very tricky. Developers have to learn that which particular event is going to get triggered in which sequence. Okay, so a lot of developers were reporting, okay, Sakshi, I am going to share the PPT with you. Okay, so don't worry. But I would still suggest that you keep a pen and paper, all of you. Please keep notepad and pen or something, some writing material with you, especially when we get to the, the functioning of model view controller architecture, because when we do the demos, otherwise you will be lost. If you have that diagram in front of you, it will help. Okay, so we're going to manipulate the control hierarchy at runtime without getting view state errors or finding that some event handlers mysteriously fail. So developers told Microsoft that when they were, everything is fine when you have static controls on the page. But what about dynamic controls? For example, if you go to Flipkart and you decide you want to make a payment, Flipkart gives you a lot of options for payment. You can either make payment by a mobile wallet like PayUmoney and all that. You can also make a payment by credit card, debit card, cash on delivery, so many options. So all these text boxes and drop down lists are not pre-populated on the page. Okay, they get injected dynamically on the fly. So only when you select credit card, you suddenly get a text box that is injected there, which says, okay, now enter the credit card number, CVV number, authentication, whatever. So when you do that in an ASP.NET page, it becomes challenging for developers to track what is the sequence of events that are going to get fired now, because it's not static control creation, it is dynamic control injection. And because of that, the page lifecycle was, completely dropped. So those tricky 17, 18 events that would trigger before the page rendered have been removed now. So the next thing that developers told Microsoft was leaky abstraction. So when you create a web form and you drag a control from your toolbar in Visual Studio and put it on the web form, there is so much that is happening behind the scenes, and there is so much code that is injected in the page that, as a developer, it's very frustrating to even modify that code, because you don't know if you change something, what is going to break. So generally, we don't bother to touch that. Okay, and with new technology stacks like HTML5 and responsive web design and all that, you actually have to get into the code and make a change. But most of the times I've seen developers working, somebody calls me and said, Arey, I touched this thing in the ASPX file and now the page is not rendering only in the design view. So what do I do? And then they kind of delete it and try to create a new file and start from scratch, and it's irritating. So the web forms really hide a lot of the underlying HTML, and there is too much of HTML getting generated with so many attributes which are unnecessary, and hence makes the developer's life difficult to modify. Testability. Okay, if all of you have heard of agile project management that most organizations are following today, in agility, everyone follows something called as the test first principle. So nobody writes code first. Okay, everybody writes the test cases first, and then they write code to pass the test cases. That's what you call as test driven development. So in test driven development, it's very difficult to use a tool and then get it done with an ASP.NET page, because you don't have everything segregated, whether it's your UI or whether it's your entity classes or whether it's a database. Everything is kind of dumped into the thing. All you have is two separate pages. You have a ASPX and you have a ASPX.cs. Okay, but that also does not really effectively help to do very good unit testing. So since the UI is completely decoupled from the CS file, I cannot individually go and test the UI without actually pulling some code from the CS file. So the unit testing for me from a test driven perspective is also challenging, and that's what developers reported to the community. Integration testing was another challenge. If you are using tools like Team Foundation Server to do a consolidated build on a central repository, and you're using something like continuous integration, where every time you make a change to the code, you're actually checking in the code into your repository and then doing a continuous build, and all of your test cases getting executed every time. So if the entire testing process at your end is automated, it becomes a challenge with a web form to do it, because you cannot selectively pull out only small bits of the code and then put it onto deployment and actually try and test it there. Now let's go to web development today. If you look at the web development today, it's no longer desktops. It's all devices and smartwatches, and I don't know what kind of every day there's some new thing that pops up via a new device via which you can access something. And because of that, HTML, CSS, JavaScript, and these are the technologies that are trending today. So, I was doing some interviews for my organization some time back, and I'm unfortunately on the interview panel. I'm the guy who comes on Saturday, Sunday, and sits the entire day interviewing people as a social service work for my organization, so that we meet our recruitment targets. So when we do that, we look at the CTC that people ask for, and strangely, I've been looking at a trend where server-side programmers today are not that much in demand as client-side. So somebody who knows JavaScript, object-oriented JavaScript, Angular, Bootstrap, Backbone, and Knockout, and can do deployment on Node.js is a much preferred guy for us as compared to somebody who knows server-side ASP, JSP, servlets, and all of that. So with the devices coming in, the entire structure of how we are programming, we don't want too much at the server side. We want as much as possible on the client side. And ASP.NET web forms are completely isolated from this stack, because all this, 10 years back, if you told somebody you were using JavaScript and HTML to build your web page, they would have laughed at you and wondered what's happening. Have you completely lost it? And today, it's all about pushing things to the client side, because you want lightweight websites. You want things opening up on devices which have limited bandwidth, and you don't want too much of response time to be taken up. So the maturity of JavaScript libraries are all-time high. Okay, these are the things that people are using today to develop apps, and most web pages are kind of moving to this. But obviously ASP.NET web forms are completely isolated from all this, because it's all server side. There's nothing much you can do there's no out of the box support for implementing any client side framework like these. REST, okay, is the way to go. So SOAP was how people were communicating with web services in the past, and this is the new protocol that we are using for micro web services architecture that's trending these days. ASP.NET is completely isolated from this, because when ASP.NET was there, all you had was a service-oriented architecture and a traditional ASP.NET web service. You did not have a web service returning you JSON data like we do today. You just had a web service returning you XML data, and that's what ASP.NET, traditional ASP.NET web form is designed to do. So the SOAP technology today is kind of moving into the background, and REST is what is coming into the foreground. where you just punch in a URL on the web browser and you get your data from the database. So you kind of access your data in a completely lightweight way, and you don't need any database layer, you don't need any backend, you just need JavaScript, you just need a URL, and if you have JavaScript and a URL, you simply punch the URL into the script and it will get your data from the server side. Okay, that's how the RESTful microservices work. So for example, if I want to delete a data from my URL will be this, so I just provide this to JavaScript and my record will be deleted on a button click, purely client side, no server side interaction. All that I will do on the server side is access this URL. Okay, and if I want to probably insert a new record, I will say URL/customers and the name of the customer, Arnold Smith, and that record gets inserted into the database. So that's something that we are all using today with these client-side stacks, and obviously web forms was not around or stands nowhere when it comes to implementing this unless you try to forcibly inject JavaScript into the form. So web applications don't serve HTML today. They also serve JSON, which is JavaScript object notation, and XML. Right, and this happens with RESTful services, and obviously you don't have very good support for handling HTTP based REST URLs in a ASP web form. Agile and test driven development. Okay, now in the .NET framework, traditionally Microsoft said, okay, only Microsoft. So when you go to a restaurant, your tablecloth and your spoons and your glasses and your chairs and everything has to be Microsoft. Otherwise, there is no way you can develop a Microsoft based application, right? Even today, in Java, you go to a restaurant and you can pick and choose. Your tablecloth can be something else, Apache Tomcat, JBoss, WebSphere, WebLogic. You can pick and choose with so many deployment options. But in .NET, yeah, Abhishek is saying, what do you mean by agile? Abhishek, okay, let me give you a quick perspective here. Agile is a project management methodology. Now, how is it different from standard methodology is, in a standard way that we deliver, what we do is we go with a big bang approach. So we tell the customer, so the customer comes to us saying that, I want to build a shopping cart, for example. So we tell the customer that, okay, your shopping cart needs to be built. So you give us 6 months and we will give you the shopping cart. Okay. So the customer says, fine, I will wait for 6 months, and they sign a deal with us, and then we start the development thing. We do the design, we do the database, and we create the screens, and then we do some connectivity, and then we show it to the customer saying, see, this is what we have done, after 2-3 months. And the customer says, okay. Now there are two options. The customer may like it or he may not like it. Okay. If he doesn't like it, our 2 months effort is wasted, and then we just have 4 months left, and the customer is putting pressure, and then we've got to sit late, and and we're not sure whether what we are delivering actually the customer is going to appreciate it or not. So in agile project management, we reverse the process. So what we do is we give the customer working software every week or every 2 weeks. So if the customer says, I want to build a shopping cart, okay, what we do is we create a login screen for the shopping cart, we create a database model, we create the middle tier, and we actually get a complete login operation working, and we demonstrate the working software to the customer. We don't show the customer reports saying that this is how much my resources have worked, and this is the utilization of the resource, and this is the number of bugs I've got, and these are the test cases that are passing, because that adds no value to the customer. The customer is more interested in the product that is working. Simple example, if you go to electronic store and you order a customized let's say a customized laptop, right? Now imagine if the store tells you wait for 6 months and then your laptop will be ready, and then you come after 3-4 months and you don't like what you see. Okay, so option 2, every week or 2 weeks the store calls you and says, see, now we have the screen working, is this fine? So you actually touch the screen and see how it is, and then you get a feel of it and say, okay, great, I like this or I don't like this. So if there is a change, it can be incorporated immediately. So there is a higher probability that you will accept what is being delivered to you. Okay, that's how agility works. So coming back to the shopping cart example, every 2 weeks we are delivering a complete working product to the customer. So week 2 we give him the login screen, week 3 we give him a screen where he can add products, week 4 we give him a screen where he can buy products, week 6 we give him a screen where he can actually do the billing for products, then we do the error logging, and so every 2 weeks he is actually able to click here, click there, and use the product and give us feedback in terms of what he expects. So that's how you deliver in agility, where you don't wait for the end of 6 months, 1 year. You don't have a 6 months release or a 1 year release or a 2 months release. You actually release working software every 2 weeks. Okay. So in that kind of environment, these are the frameworks that third party developers have actually created. You'll find all these frameworks on codeplex.com. So there is NUnit, there is XUnit, NInject, AutoFact, continuous integration servers, which are cruise control TeamCity, and ORMs like EF and Hibernate Subsonic. So this is what industry is using today. Okay, now this is what you can. There is no way you can use this with a ASP.NET web form. Impossible, because a web form is not designed to actually allow you effective segregation to bring these frameworks in. So industry is using something else. Industry is telling vendors and telling customers that, boss, we can deliver to you in 2 weeks working software in small increments, so you can actually see how it works. You don't have to wait for 6 months. But .NET, the ASP.NET model doesn't allow you to integrate these tools, which means you cannot work in an agile environment. Okay, and any tier 1 organization, you take a Capgemini, you take an Accenture, everyone today is delivering in agility. Okay, nobody will tell the customer today that you wait for, we'll do 6 months releases, we'll do 1 year releases. Customers don't want that. They actually want working software in immediate 2 week, 4 week increments. So and some of you all may have heard of the Scrum framework. So Scrum is a project management methodology that implements agile and that facilitates the entire team to deliver in these short increments. So this is another reason why we do not want to use web forms, and we definitely want to go with MVC, because MVC is aligned to integrating with these frameworks, okay, which you will also see when we do the hands-on. So if you look at web development today, JavaScript is the language to go. Okay, if you know object-oriented JavaScript, you're in demand. Ajax is the thing people want to use. Okay, jQuery is on top of the line. Now people used to say that, oh, JavaScript is very slow, but with Google's new open source V8 JavaScript execution engine, the way JavaScript executes is the speed is absolutely the same with compiled language. So whether you take any compiled language like Java.NET or you take JavaScript, the speed of execution is now on par with the research on the V8 execution engine for JavaScript that is done by Google. So when you're using Chrome and all that, you're actually using the V8 execution engine of JavaScript, which is inbuilt into the browser, which actually gives you high speed JavaScript execution, and hence it is fast, so there is no performance delay that you will see. JavaScript is also moving to the server side. Okay, so it's no longer a client-side language. You can actually execute JavaScript also on server side. And how do you do it? When you actually say script, your script tag, and then you say language equal to JavaScript. This is how you inject script into your page. Okay, and now you want your script to execute as server side, so you simply say run at equal to server, and you can have your JavaScript executing as a server side option as well. Okay, and if you heard of big data, everyone is talking about unrelational databases today. So if you talk about big data, these are the tools that people are using today, CouchDB and MongoDB, and they have been built using JavaScript. Okay, now why have they been built using JavaScript? Because when you're working with SQL Server as a database, let's say you have 1 TB or 2 TB or 5 TB of data. Okay, in that case, a query will work, because you write a query, a select query, the query will hit the database, it will be optimized via some indexing that you are doing, and it will get you the data. But when I talk about big data, which means I'm talking about, let's say, 30 petabytes of data or 60 petabytes of data, something that Facebook generates every day. So if you're talking of that amount of data, and if I try to fire a select command on that, it's going to take ages for my data to come back. So JavaScript is the only language which is interpreted, it's not compiled, and hence the way JavaScript works with a big data solution is it only executes part of the code, fires that on the database, and gets you only an instant result of partial execution. So if you have 20 lines in your select command that you've written in script, it will only execute the first 5 lines, get you that much data back, so that the user does not have a lot of waiting time. It does not wait for the entire thing to compile, execute, create an execution plan, then give you the data. That's not how JavaScript works, and that's how they've leveraged, most of these big data vendors have leveraged the benefit of JavaScript and used it as an effective server-side solution for big data non-relational databases. So Node.js, Okay, it's Node.js is the new web server that's also built on JavaScript. So if the client is JavaScript, the data solution that brings data to you is JavaScript. Obviously, your web server has to be JavaScript. It cannot be IIS, or it cannot be web JBoss or WebLogic or something. So Node.js is the web server that's now being used, and it's completely built on JavaScript. Okay, it's also the only web server that has a non-blocking I/O and works in an async manner. Now, what does that mean? Let's say you are creating a ASP application and putting it onto your IIS web server. Okay. Now, if you have 100 users that are connected to the web server, each user will be serviced in a separate session, which means there are 100 objects that would be created on the server side, or 100 parallel threads, and each user would be serviced in that specific thread. Okay. Now, in Node.js, it magically services 100 users in just one thread. So the algorithm has been very intelligently written, where the scale up is very good. So the moment you scale up your number of clients, you don't have to worry about too much RAM on the server and the server going down and all of that, because Node.js can equally manage n number of users in a single thread. So that's the non-blocking IO and the async features. It's not synchronous, so it doesn't wait for one user to get serviced and then moves on to the next user. It can parallelly service n number of users, and that too in a single thread without blocking the experience of any user. So that's why it's being preferred as a deployment mechanism today. And I'm sure when I'm going through these features, you would understand that ASP.NET Web Form stands nowhere in this race. I mean, there's no way you can do a deployment of all this, because there's no immediate JavaScript integration that you can do. So why are we using MVC? Because it's aligned to what is trending these days. Okay, it includes an async controller that supports non-blocking IO, which means you can scale up effectively. You can handle more number of users per CPU as compared to a traditional ASP.NET Web Form. So it is aligning to what Node.js is actually doing. Okay, it produces standard compliant HTML markup. So it does not give you, when you drag a control onto the form, it does not give you that noodles like thing with so much of code that it frightens you to even try to modify it. Okay, it encourages you to craft very simple and elegant CSS. Rather than the master pages that you had there have been removed. You don't have the concept of master pages now. You just put a CSS over there. Okay, it supports jQuery and Bootstrap. So it is aligning to JavaScript now as compared to what we did previously. It supports test-driven development. Hence, it supports Scrum, project management, and also agility with program development. So to your customers, when you are signing a contract, you can actually tell them that, yes, if I'm developing an MVC, I can give you working software every 2 weeks, every 4 weeks in an agile environment. Okay, unlike a waterfall model. So in a waterfall model, we used to say wait for 4 months, wait for 6 months to see something working. Till then, we used to only show PPT, we used to only show PDF, or we used to only show wireframe and screenshot. Okay, that's not what customers want these days. So implements separation of concern. Yeah, please go to previous slide. Yes, I'm on the previous slide, Shivangi. Okay. So test-driven development, separation of concern, inversion of control, and dependency injection are these are all patterns that MVC implements, and I won't get into explaining them because it will be stupid of me to explain them on a slide like this. It will make more sense. You are all developers and you will like to get your hands dirty with the code. So when we do the code, we will understand how to do this. Okay. This is what I explained to you yesterday, that there is an entity, boundary, data store, and controller, and we had one flow like this that we actually created in the MVC style. Okay, so I want you to spend 1 minute, just go through this flow, and please ask me if you have any questions, because now I'm going to give you one flow that you're going to develop by yourself. Okay, so just go through this flow for a minute, then I will give you one problem statement. Take a paper and pen and try to draw a sequence. This is a UML sequence diagram. So draw a sequence diagram like this, identify your set of classes. Yesterday I have given you a technique, if you remember. I will just put it up, right? We had discussed this, how to identify the right set of objects, right? This was the grid that we discussed. So this is the technique that you are going to use, and you are going to create this flow by yourself. Okay, so go through this, ask me any questions that you have, and then I'll give you one problem statement that you will do by yourself. Okay, so I'll just run you through this again. So this is the use case for how are you going to design classes for a customer who's going to bring up, issue a new book to a member. So the controller is going to talk to the UI screen, which is the boundary class. The UI screen will take the data and return all the data back to the controller. After which we are getting a member from the database. So before issuing a book, we need to know whether the member is registered or not. That's the reason I need to call a function called getMember, which goes to the data store, which talks to the database, gets me all the information from the database and returns that information to the controller. The controller uses that information from the database to construct an object of type member, which is the entity class. Okay. Then the controller is calling a method on that member object, asking it whether this book can be issued. Is it a reference book to be kept in the library or can it be issued? Okay. If it can be issued, that same object is thrown by the controller to the book copy store, because we need to know whether is there a book available for this member in the database. Okay, so that information is sourced from the database. The book information is received by the controller. That same information is thrown by the controller to the book copy class and a new book copy object is created. Okay, we call a method on that object. Can this book be issued? Okay, so so this actually is not a book thing, but it's can the member be issued a book? So that's a typo from my end. This should be, can the member be issued a book? Is he a valid member or is he a member that is already having his membership expired or whatever? Right, so we check if the book is issuable or not. If it is issuable, that information is available with the controller. The controller then calls a constructor of type issue, creates a issue object. So an issue object will have two things. It will have member information and it will have book copy information. So the member information will be available here, the book copy information will be available here, and that will go to persisted into the database. Okay, so that's the MVC style flow that we will have for adding a book or rather issuing a book to a member. Okay, is this clear with everyone? Can I move on to a small problem statement that I will give you? Do all of you have pen and paper with you? Okay, so please do not discuss with anybody because there is no right or wrong here. Okay, I want you to give me your thought. Whether you're right, whether you're wrong, doesn't matter. That's not what I'm concerned about. Okay, for that design thinking to come out, I will need to understand what you are thinking. So don't discuss between yourselves and give me a consolidated thing. Give me your individual input so that I can make a correction wherever required. If you give me a consolidated input, then I cannot correct too much. So I'm moving to the next slide, which has the case study. This is what we want you to do. The use case is a new book should be added into the library. Okay, so the librarian has received a new book. You have to add this new book into the library. Can you please identify the objects, put together the sequence diagram like what I showed you? Okay, adding a new book to the library. I'm keeping this previous diagram open to assist you so you can go through it. I'll just discard everything so that it's much more visible to you. Okay, so 5 minutes to do this. Okay, 11:30 I'm going to give a tea break for 10-15 minutes. So by 11:30 we should be done with the slides. We'll then take a tea break at 11:30. We'll come back in 15 minutes. We'll do the SQL installation thing together and then we start with the hands-on. Okay, that's the plan. Okay, just ping me once you are done with your design, and then I will put up the ideal design and we will discuss, and if you have any queries or questions for me, or if you would like to debate anything, please let me know and I would explain all your queries that you have. Okay, so just keep putting the word done so that I know that you all have completed, and then I will put up the solution slide. Okay, Priyanka looks good. I think Shivangi is also done. So if any of you need a conversation with me, you can unmute your mic at any point of time and you can speak so that we can discuss. Abhay, book controller, create form, staff store. Okay, Abhay, I did not get what is staff store and what is book copy store is okay. And instead of create book, it should be book. The name of the class should be book. Okay, create book is more like a method. It sounds like a constructor. So it should be book. And staff store, I could not get why did you add a staff store there, because it was more about book management. Add a controller to call book copy store and add new object of book copy. Okay. Okay, staff store you have added because you want to track the details of the staff which creates the book. Okay, but Abhay, the moment the staff or the librarian logs into the system, the credentials would be available with us, so we would know who logs in. So we would not need to go to the database at when we are adding the book. We will go to the database when we log into the library management system, because that is the time you will validate whether this librarian is the correct user, and that information will be pulled into the screen telling the user that this is your librarian ID and all that. Add controller, add book, bookstore. Okay. All right. So let me move to the solution here for all of you. Now you can see here that the librarian as an actor will communicate with the main screen. Okay. The main screen will talk to the book title controller because we are going to add a new book title. Okay. Then the controller will bring up the book title screen so that information can be added. All the information that is added in the book title will be thrown back to the controller. Okay, the controller will then take that information and will throw it back to the book title to create a new book title object. That book title object will be pushed back to the controller. The controller will take that object, give it to the store for persistence. So if you look at the code we would have been writing in the book title controller, The controller will say add data. It will take a string of values. It will construct an object of book title. It will construct an object of store. It will pass the book title object to the store, which will save it. And if you look at the code of the store will simply take the book title object and fire an ADO.NET command to insert into the database. Okay, so I assume that you guys are clear with this. If there is any questions, comments for me, any discussion, please ask. Repeat again. Okay, Mayur, I'll repeat again. One sec. Let me discard my annotations. Let me run. Okay, so first thing, librarian will bring up the main software screen. Okay, the main software screen, the moment I call the book title use case saying I want to add a new book title, I'm going to call a function that brings up the controller, which is going to be the book title controller. Okay, the book title controller is going to then throw us a form by calling a show command on that form saying this is the form or the boundary class through which okay, Rachna, I'll come to your question later. So I'll just address Mayur's question first. So the book title form is here now. I'm adding details into the form. Okay, so that is the data entry that is happening by the librarian into the form. Whatever data you've added into the form is thrown as individual variables to the controller. The controller takes those individual variables, passes it to the constructor of book title and constructs a book title object. That book title object is given back to the controller. The controller takes that book title object and throws it to the data store for persistence. And that is what you see here. You look at the code in the controller. These are a set of values that have been entered in the screen. We picked it up from text boxes. We passed all that values to the constructor and created a book title object. Okay. Then we created an object of the store and we simply pass the book title object to the store. So here is the store which takes the book title object and inserts into the database. Mayur, are you clear? Okay. Rachna, any updation, one second, any updation, how will controller, any validation, how will controller work? Example, duplication of book title. Okay. So in the book, what you can do is, you can have a method in the book title class, okay, which says check for book title. Okay, and typically there will be only one book title, but there will be multiple copies of that book. So in case the title is already added, the software should tell you that yes, this title is there. You just want to do a +1 on the copy. Okay, so in the controller, I will call a method in the book title which says validate for duplicate values. Okay, so the moment the user enters the book title and hits end or presses the tab button, that is where we will call the method and check does the book title already exist in the database. We'll prompt the user that these book titles are already there. Do you just want to do a +1 on the count? Okay, Rachna, does that answer your question? All right. Okay, so let me move on. I think all of you have got a perspective of what we are trying to do here. I'm going to move into the core architecture of MVC. Please get your notepads out because this is the crux of what we are going to decide. Now, please understand that in an MVC project, there is no concept of code behind. So you don't have an ASPX and a .cs file. You can never use a server-side control in an MVC project. Okay, now you'll ask me, how strange, why don't we use a server-side control? If you use a server-side control, you will have too much of code that is getting injected into the screen, like in traditional ASP.NET. So we don't want that. And secondly, I also told you that there is no view state. Okay, so if you want better control over HTML5 and if you want standards-driven structures that you want to your page, so you will have to create an HTML5 content, because remember today my first slide says that the user is accessing content from different devices. Okay, so if the user is accessing content from different devices, you obviously want your content to be standards based. So it's going to open, it's going to be responsive and it will open on any device. So if there are no server-side controls, you don't need a page lifecycle that is there in ASP.NET. So that's dropped. And if there is no server-side control, why do you want view state? Enable view state equal to true was a property we used to set in ASP.NET. We don't need it. No postbacks are required if you are just working between the model view, because this is more of client-side MVC, and I'll explain you the difference to that. If you don't have a server-side control, when I click on a button, the button is a client-side HTML button, right? So why do you want to go to the server to execute C# code? You write JavaScript code, execute it in the client. Sessions are supported. Separation of concern is there. It is easy to test because the code is independent and not coupled with the UI. Okay, the view and the model are completely separate. So this is a basic overview of the key features of what MVC has to offer us. What you have to remember is, from this, no server-side control, no view state, no page lifecycle, and we are working with typical HTML5. Now, I want to ask you a question. Does Microsoft anytime create, for example, .NET framework? Okay, is the .NET framework open source? Is the .NET framework like Java? Now think before you answer. Huh? Don't just give me random answers. Okay, all of you are saying that .NET framework is not open source. I'm sorry, you are wrong. And the reason you are wrong is because I remember I think 5 to 6 months back, I just attended TechEd. I'm sure you know what TechEd is. TechEd is the annual or the bi-monthly platform, or the 6 monthly platform that Microsoft has. So any new product launches and on Microsoft does it at TechEd. Even you can go to microsoft.com TechEd and register yourself. So I was just interacting with the Microsoft team for the new features that they were demonstrating to us, and they shared at that TechEd saying that they are open sourcing the entire Microsoft Azure cloud stack because they wanted third-party developers to sit and integrate with that API, and the same thing that Apple has done. So the reason Apple phones are so popular is not because of the phone, it's because of the ecosystem they've created around it. So Apple Store and all of that is where developers create their third-party apps and the API that they've exposed. So .NET has done the same thing now. So all .NET products going forward are going to be open source, so third-party developers can communicate with the APIs and also create something innovative. So if you want to see the entire code that has been written behind ASP.NET MVC, you can do that. So this is where you can do it. You can go to aspnetwebstack.codeplex.com, and this is what you will see there. You will see the entire source code of ASP.NET MVC, which has been exposed on the web. You can download it and you can get inside those classes and look at how the MVC structure for ASP.NET has been created. So the entire source code is available for free download, and you will see this happening for most Microsoft products now. Even the Azure stack is what is going to be open sourced, is already open sourced actually, and most other products going forward from Microsoft will be open sourced. And of course, you understand the benefit of open source. You will get they get feedback directly from the community and a larger adoption as well, and a lot of third parties developers integrating with them to create apps. So if you look at this, I just went to Codeplex, double clicked on one class, and I can see this is Microsoft source code that has been written to create the MVC framework. Okay, let's move on. So some of the benefits of using MVC, one is URL routing, which I spoke about yesterday. So instead of your URLs looking like this, okay, they now look very clean. The URL looks like this, a very clean URL, not very long, because you're just interacting at the controller level and everything behind the scenes is hidden. Okay, so there's no security risk of copy pasting URLs and messing it up, and then you having to keep clumsy session variables to check does the user come from this page and that page and all of that. Okay, now please write this in Notepad or somewhere in your books. This is very, very important, that the pattern of the URL in MVC project is controller name and action method name. Okay, please mandatorily write this down, otherwise you will not know how to execute your projects once we write the code. Okay, so everything in MVC is controller name / action method. Okay, what this is, I'm coming to it. Controller name, I have already explained to you. It is the class that has the functional flow of the application. So that's going to be your controller name. Okay, and the action method, I'm coming to that. If you want to see a fully fledged website working on MVC, ASP.NET MVC, please visit stackoverflow.com. If you all are developers, I don't have to tell you what is Stack Overflow. So please go there and you will see, look at the URL. It's a very clean URL. And it's because the controller is getting hit, which is giving you data from model and the view. Okay, so let's look at controller, model, view. Okay, we've already discussed, so I'll take you through a flow, an illustration which will explain the entire thing to you. So step one, an end user is coming to our web page and hitting the controller. So he is asking for some controller saying login. Okay, the controller will now go ahead and start searching for a model. It is not mandatory that a controller should have a model. It is optional. Okay, if the controller finds a model, it can pick it up. If there is no model, it will just skip it and it will start searching for a view. So step 3, if the model is available, the model will be serialized and passed to the view. If not, directly the controller will start looking for a view. Okay, once the view is found, the view will transform the data that is there in the model into HTML5. Okay, so that it structures it into a table on the page and all that, adds the CSS if required, and that is what is thrown as an output to the end user. So this is the illustrative flow of an ASP MVC app. I'll just run it again. Step 1, user hits the controller. Step 2, controller looks for a model optionally. Step 3, model is serialized and passed to the view. Step 4, the view takes the data in the model and tries to create a HTML representation of it, and that screen is then shipped as a response to the end user. Any questions with this? Okay, no questions. Move on. Now this is server-side MVC, okay, where the model, the controller, and the view are lying on 3 different servers. The model is there on a separate box, the controller is hosted on a separate box, and the view is hosted on a separate box. But with ASP.NET MVC, it is actually client-side MVC that you are creating. So the entire thing is on the client side. And the only reason why you want to go to the server is to do a RESTful web service call at the server end. Okay, so the browser will talk to the controller. The controller will ask for data from the model. That is when the model will give a RESTful service call. It will get the data in JSON or XML or raw format or whatever. That data is thrown back to the controller. The controller will then serialize and pass it to a respective view. You may have multiple views. The end user never knows which view is going to be returned to him. That is completely the developer's decision. Okay, the view will take the data and represent it in a DOM format. Okay, DOM is document object model. It is how your data is represented in HTML structures inside a web page, and that data is shipped to the browser. Any questions with this? Okay, so this is how it works. DOM is an object of the window. Okay, DOM is actually how DOM is a set of, it's an API that has been released by W3C, okay, that allows you to interact with elements in your page. So if you want your HTML elements to be removed, deleted, added, inserted on the fly, as developers you all must have used a get element by ID, very famous method that we use. So that is a DOM method. Okay, so a get element by ID is a method that is a DOM method which is platform independent and which has been released by W3C. Okay, so W3C releases the DOM API which any language platform technology can implement. You can write DOM code in JavaScript, .NET, C#, whatever, core Java, and manipulate the page structure. So here you go. For the model, you can use a flat class or you can use any ORM of your choice. Entity Framework, Subsonic, and Hibernate. Okay. For the view, it is nothing but a set of ASPX or Razor files. Okay, what is ORM? Okay, Abhay, ORM is Object Relational Mapper. Okay, let me explain that quickly. So what ORM means is that if I have a database, okay, and in the database, if I have a customer table, okay, I am going to create in my middle tier. When I say middle tier, I mean my data access layer. Okay, I'm going to create a class called customer. So customer.cs. Okay. Now this is the customer database. So this is the table that exists in the database. Okay. This is the C# class that exists in the middle tier. Okay. And then I have a view which may be a ASPX page. Now what I want to do is I want to sync whatever is there in the database into this class. Okay. So that Generally, when we program, we just avoid the middle tier. Okay, we don't actually bring in the middle tier. That's removed. We just talk about view and we talk about database. So it's not pure object oriented programming. So what we are doing now is we are taking data from the database, constructing an object out of it in the middle tier, and in the view we are working with these objects. We are not working with the database. Okay. So this interface between the database and the middle tier is what is called as an object relationship mapper. What it does is it maps your table fields into a real life entity. That's why object relationship mapping. So exactly what you have in the database, it's going to map as an entity class, and that entity class you're going to display and talk to in the view. And from an MVC perspective, this entity class is what is called as your model. So you have two options. Either you create this model yourself or you use frameworks to do it. Frameworks that will automatically generate the model for you. Entity framework, Hibernate, Subsonic. Either of these, whatever you want to use. Okay, Abhishek, after ORM, please clear what is repository and is it good to use repository when entity framework is used? Abhishek, repository is a design pattern. There are two patterns that entity framework uses, repository and abstract repository. So I'm going to do a demo. If I try to explain to you a repository on a notepad file, it will go haywire. So since you guys, developers always prefer hands-on. So in the hands-on, I'm definitely going to touch upon repository. It's there in the course content. So please hold on till then. And when we implement entity framework, I will show you how to use and what are the benefits of using the repository pattern. Okay. So model view is fine. Now the view here, you have multiple options. Okay. As part of the view, what are the options you have? You can either use .aspx, you can use .cshtml, which is Razor. Okay, that's the view engine, or you can use around 12 other options that are available to you. So you can switch whichever view engine you want to use, and the view engine is kept separate for a reason, because if you're a .NET developer, you use Razor or you use ASPX. Okay, if you're a Java guy who is first time you're using .NET, there is another view engine which is very similar to Java code. Okay, so depending on which technology you come from, you can switch and use any view engine of your choice. Is ORM secure? Alok, ORM, I don't really understand your question from a security perspective, because the reason why an ORM is there is because it replicates data from the database into class structures. Okay, that's what it is there for. It is not meant for securing anything. Talking about SQL injection, okay. Alok, there is no question of SQL injection with an ORM. Reason being, you are never talking in terms of commands. So let me. I hope I can do a Control Z. Okay, unfortunate. Okay, so when you are talking about SQL injection, what you traditionally do in a web form is you say, you call a stored procedure or you call a command which says insert into database where value equal to this. Now that is where the user can inject some tricky SQL statement into what you've written. But when you are working with an ORM, you are never talking to the database. You are working with objects. So you're saying, collection.add object. That's all you're doing. You're never passing SQL statements through the bandwidth. It is when this collection.add method is encountered by the ORM does the conversion into relative SQL and pushes it into the database. So the front end never gives, or the views never give SQL to the entity framework. It just gives a collection.add. So it's just add, delete, and you're working with objects. So please understand, that's the reason I emphasized what is an object, and I emphasized the entire design pattern of OAD and MVC. So here you're working purely with objects. You are never going to touch the database and talk about ADO.NET and say connection.open and SQL command.execute and execute data reader and execute non-query. You're not going to write that. You're talking in terms of objects. So you're saying collection object.add, collection object.delete, collection object.update, and you will pass a object of customer to update. And the entity framework will take that, write the SQL and get it done at the database end. Okay. All right. So these are the choices of view engines that you have: Razor, Braille, Django. If you're using Python, Django is excellent. Sharp, Sharptiles, and Haml. You can use any view engine of your choice. Okay. We are going to work with Razor because that ships with Visual Studio. Now this is the standard folder structure that you see in ASP.NET when we will create a new project. So you see a whole lot of folders, and it is not optional, but it is mandatory that you put the right thing into the right folder. So please pull out your notepads and please take this down. All controllers have to go into the controllers folder. You can't keep them somewhere else. If you keep them somewhere else, the system will not find it. Okay. All models have to go into the models folder. All views have to mandatorily be put into a views folder. All the JavaScripts have to be put into a scripts folder. All images have to be put into an images folder. All CSS has to go into content. All data store files that you want to read and write to should go into app data. All configuration for routing, bundling, web API have to go to app start. Okay, this is something you want to take down, because when I say create a new file, you will ask me which folder should we create this file. So I'm giving you the folder structure right at the beginning, so you know during the demos when we say create a view, it has to go there. If I say create a JavaScript file, you know which folder you need to create it inside. Okay, and please understand this is not optional, because MVC follows something called as convention based programming. So if you are not putting the right file in the right place, you have to log and write a very cryptic web config file. So in the web config file, you'll have to tell MVC that this controller location is this. Okay, the content is lying over here, the images are over here, and every time you make a change, you'll have to update that config file. So to avoid that, you use the convention, and MVC picks up the right thing from the right place automatically. Yes, Abhay, I'm taking a small tea break. I'm nearly done with the slides. So once we're through with this, we kind of break for tea, 15 minutes, and then we'll come back. Okay, let me, yeah, I think I'm done with the slides. So the slides are done. Okay, so once you're done with this, we'll go for a tea break, 15 minutes. It's 11:42. So I think 5 to 12, we'll come back and continue. And then we have, we'll just get to the SQL Server installation, and we commence with hands-on. Okay, if there are any questions for me, you can